Right, hi. Welcome to this tutorial. This one is an expansion on a section in my 10 things you already knew about SSIS talk that I've done and I'm doing at SQL Saturdays. This is an expansion on the Delta What section, where I briefly touch on, in the event or in the talk, I briefly touch on delta loading techniques, pros and cons, what you should and shouldn't do. What is appropriate, what is enterprise ready, and what kind of patterns are appropriate, why they're appropriate. So in this video, I'm going to go through the Git project, the source code, and I'm going to just walk how to run this lab end to end. So let's get started. So first thing you do is you go to the Git repo. So that's under GitHub /ex-tc, and then you'll see the Delta load project or repo. You go ahead and download the database files you need. So there's these are all, I think they're SQL Server 2012 backups. Or backup files. So you need the one source, which is a world geography source with some other table or two other tables in, and then two destination um, um, tables, right? So you go ahead and just download one of the back files or the back files. So I've already restored the Delta source. So I'm just going to go ahead and I've got the other one downloaded. So I'm just going to go ahead and restore them. So we do this end to end. I think I had them here. So that's the destinations. So let's just take first one, off we go. And we're good. So that was the FNV one. Let me take the next one. And there we have the databases, right? So these should be empty, I believe. Yes, they are. Right, so these are empty databases. The source database is or source table that we're going to be loading from is a geography data set. It's a simplified one. You can use this for world geography. It's down to state level. We're in the UK where it's country level within the United Kingdom, but that's just the UK. But it's on the sort of that level. Then what we do is we go ahead and download the, you go and you clone the repo. You want the Visual Studio code, so you download the Visual Studio project. You go ahead and open that one. And so I just need to tag these ones. Once you've got that, you then have a couple of packages. Fix up any connections. Obviously, they should. If you've got a named instance, these won't work. If it's default instance on your machine, they'll work out of the box. Okay, so let's start looking or explaining the project. I've got a controller that executes different packages, and then you can see how long each and every one took and sort of understand what they are. The first section I want to go through is There's different hash techniques. They're all the same. Um, this hashing technique using FNV1A block cipher as a hash folded into um, a big int. There's the hash bytes folded into a big int, and this is my favorite one. This one works the best. You can, well, we'll add some code. So the FNV one was used in case you had text data. So you had different or text data sources. So you had a different way of handling or non-SQL way of handling hashes. I've got the code, the scripts to use or generate um, the same hashes um, as hash bytes folded into big ints using C# scripts, and I'll upload those into the source repo as well as code snippets. That will happen in a later time. Right, so let's get started. So what is the delta load? So this example we have we load data into a staging table. Or let's walk the data for. So we take some source data. We look up the business key hash to see if we have it. So let me show it here. So we've got a business key that we've compressed, and I'll show the select that builds the business key. If we get if we get a null back, then we have new. So in other words, we didn't find anything. If it's existing, then we drop it into or we look up the delta hash, and if the delta hash of the record, and let me show you here. So let me look up, try to join the business key and the delta hash. If it doesn't exist, or if there's no match between the on the delta hash and the business key hash, then we want to insert into staging table, or else we discard them because the delta hash is incorrect or the same. We already have it. And obviously, if we didn't have the business key, we just insert it as a new record. Okay, so that kind of makes sense. This is a very, very fast and efficient pattern. If you got high loads or vertical tables that you're doing this on, obviously you do this predominantly with dimensional tables, large dimensional tables, but you can do this also with facts as well, and it's really, really fast. Obviously, there's alternatives to doing it this way, using slowly changing dimension transforms, and this one's broken because it needs to be rebuilt. Don't stress too much about that. Or you could do a manual upsert, but you would have to go some form of this anyway, where you would drop everything into a staging table, and then make decisions in the store procedure, and then build temporary tables, and then just final product you insert. Yeah, but that's obviously a different case. I also have a single sort of store procedure like thing where I do exactly the same, only I do the inserts and the updates by building temp tables and doing it. It's literally the same thing. The reason why I have this in is because I want to illustrate that the speeds are not so different between a TSQL action natively on a machine to a delta pattern like this. And what I also want to illustrate is that there is advantages in not using a straight TSQL. And the biggest advantage is that you get something that is enterprise ready. So you disconnect your data boundaries, your staging database, your staging tables, your servers. That can be well, everything can be on in different locations. So you're not locking yourself into running an isolated process on the local machine. Right, so let's fire one of these and let's see how they work, and we can step through the result and see what's cooking. So we're going to run let me just close everything but this hash bytes project. Oops, daisy. I like the hash bytes one because it's simple and we can walk through the source. So if first thing we just want to have a look at is what our base data set looks like. So I have a multiplier in here. I've got some randomizer. So I believe the business keys are always the same. But I have a randomizer that makes sure that every time they execute, they get a different delta hash. Right, so business key, let's have a look at the transact. So the business key is it is location ID. Oh, looks like the business key is also random every time. Or possibly random every time because I do I have a chunk column. Let's have a look at that table, the multiplier table. And there you can see the join. Uh, there is no relationship in it. So if we go and look at the source table, yeah, the junk column, yeah, it just contains values. So there's a quite a high possibility that they might be the same. There's lots of ones and twos in here. But there could be obviously some form of new records that it would generate if the values are different. Anyway, so it on occasion it will spawn same business keys, but the delta key is always a new GUID, so that will always be a new value. But yeah, so if we look at this, we can see the values, right? So business key should be the same or could be the same. Could be different every time they run as well. And the delta key, obviously, that will always be different, always random. So if we execute this, it's just so it populates data, and then we can step through the thing. So let's just have a look. So we're just going to run this. Excuse my slow machine. Here we go. So in the data flow, we push through all 79,500 rows. And as you can see here, the split, we had new records. They got inserted straight into the destination table, which is the dim geography table. And if we go and we look at the destination table, right. We can see that they're here. Okay. And we got them inserted. And there you can see, the business key and the delta key for delta hash for the row. Now, in a real world scenario, the delta would have something that could be changing, like I don't know if the spelling of the state was different in this case, or whatever it would be. But yeah. So if we go back to here and we stop this job, and we run it again, we're going to see something very different. So okay, it's executed, and now you can see that oh, we got always the same match, obviously because the table comes in the same structure anyway. So we see we got the 79,500 rows of data, 511 rows of data. We looked up the business key. We outputted everything, and all of them, all the business keys came through as a match because existing. So um, um, yeah, if it's not null, right? So is null is false, then it's existing. So they weren't null; they actually came and matched, and then we looked up the delta hash, and obviously the delta is always new. So we inserted the 79,511 rows because we had new deltas into the dim geography table or into the stage table. So we can go and look at that one. So the stage table should now contain a whole bunch of new rows. There they are. And then the final action is to update the stage table, which is a quite a simple. It's a simple simple join on the business key hash, and then just it sets obviously all the columns, all the values. So that's how this one works. And if we look at runtime, so let's go ahead and truncate some of these tables. So I'm going to go ahead and let's just do this. I'm going to go ahead and truncate this table. Okay, so our dim geography is empty, right, which is our destination, and let's just keep some time on this. So here's our full straight insert. And bang. So our fresh insert took 4 seconds and 4 seconds and a couple of milliseconds. So if we stop this guy and we run him again, and now we're doing the same, but we're doing with an insert into the staging table and then an update. Let's see, and he's completed. There. So this one took 5 seconds, or 5.7 seconds, right? Now, if we were to go and look, I'm gonna have we're gonna have an attempt of the TSQL, and let's see how that guy works. So this guy should be doing cross database joins. Yeah, this guy does cross database joins. Still using a hash byte function, or exactly the same queries. But this would effectively be the second time this one executes. So if we go and execute the task, and he broke. That's no good. Uh, right, let's troubleshoot. Let's find out why this guy broke. He shouldn't have broken. All gone broken. Let's see. This used to function 100% correctly. So he goes trunket table, dim geography. So he's already in the destination. And delta hash source. Source multiply. So this section should work. That should work. Yep. Generates first, and then he wants to insert into okay. Well, let's see that section. Yeah, okay, that worked. And then we do that, and then we do the update. And we truncate and we drop the table. Okay, so that works here. So it's obviously just, it's got the wrong connection to it. Let's just go ahead and TSQL destination, which that is broken. Why is it broken? Okay, right, it's because it used, okay, so that was me being silly, not checking that out. So I'm just going to go ahead and tell it to use the hash bytes destination table, and then it should be working. So just save that. And if we execute it now, I ran the wrong package. Let's stop that. There we go. Execute this guy. So we're chasing that 4-second mark. Let's see what we get. This one took 8 seconds. That is strange. Why did it take longer? Well, it goes to prove that let's try to run it again. Let's see if it's faster the second time around. Because maybe, just maybe SQL cached some stats on that. No, that's still slower. Quite a lot slower. 15 seconds. TSQL might not be the fastest option. Right, let's try to run this package again, and let's just see if it's not just fluke. Let's see, so this one took 5 seconds the second time it ran because of the update. And yeah, okay. It's wildly faster than TSQL. So for those of you, yeah, 6 seconds. So for those of you that believe that TSQL is faster than SIS, well, this kind of proves that it's not. Obviously, it's not optimized. We could do a whole bunch of stuff, but then to speed up the TSQL ingestions, but then you also got to remember that that will still just lock you into one server. The FNV1, so let's see if this guy works straight off the bat. There's a warning, probably truncate probability or unused inputs or something like that. Just see if that works. So this works through a scripting task. Hey, my machine is not coping right now. Okay. That is interesting. Visual Studio is hanging. Okay, let's kill it. And I bet you that solution is not going to open up again, or at least build, because the ispac file will be locked. But let's try it again. Right. There we go. So I just want to close these other two packages, and I just want to go in and just make sure everything is running. So there. Truncation may occur. Just want to open up the script and just recompile it. So maybe that will speed up things. Ah, right, there we go. Okay, so that opened. Okay, so that works fine. Let's just close that. Hit OK. Let's just try to execute this package again. And hopefully build doesn't fail because the ispac file is locked. Ooh, it did. Okay, that's gonna need to restart a computer. Yeah, okay. I think that is the end of this demo. But anyway, uh, the reason I'm illustrating a different hashing technique is the same pattern, same lookup pattern, same way of doing conditional splits. The reason I'm showing this guy is just to show a different way of hashing, and this is through a scripting task instead of natively. So in other words, we build up a string column, or we build up um, our source keys and all of that stuff. It's as string columns or derived columns. We then um, generate the hashes, and then we um, do lookups on those locally. The benefit of this way is obviously that this could be anything. Uh, it could be a flat file. It could be some external database engine somewhere else. It could be a Hadoop source. Could be whatever you want it to be. And obviously, this way of computing hashes instead of using hash bytes in a transact source, um, gives you a little bit more flexibility. Um, there's not a massive speed difference. Um, this way is a little bit slower because of the scripting task has additional buffers and actions, whereas the previous one where we're using FMV, hash bytes, that one is faster because we build it at source. And obviously, as we discovered with the transact route or running store procedures that does merges or inserts and updates, that is not faster. And you have a whole bunch of other complications. I'm not going to even entertain. There's a reason why slowly changing dimension was put in here, and that was to illustrate how slow SCDs really are as a task and why you should stay away from them um, in SSIS. It's broken, needs to be rebuilt, so we'll have a look at that at another stage. Anyway, thank you very much for your time, and yeah, I hope you enjoyed this expanded tutorial on the Delta Watt segment of my 10 Things series.